specifically for noise or
Okay.
quality or both?
Good morning, and thank you for coming. I think it's one of the final sessions of this conference. And my name is Georgios Tzamalis. I work in DG Move in the Intersection Innovation Unit, following several parts of the Horizon Europe work program. And I have the pleasure to be here with Bert Pluymers, who is from K11 and will be moderating the session, this session today. So there will be two projects presented in the area of noise and emission measurement, assessment and mitigation. This area is quite important for delivering the zero action pollution, the zero pollution vision for 2050 and the zero pollution plan, which has actually, for noise in particular, and has one of the targets to reduce by 30% by 2030 the noise that comes from transport. And of course, as we know, noise has several adverse effects on human health. And also, quite important is the implementation of this. And both of the projects work on providing solutions better to enforce, let's say, the existing regulation, and also to identify, let's say, what are the main issues that we need to pay attention to in order to reach our targets. So, without further ado, I would like to start with the first project. It's a project NEMO. And I would like to welcome Bert Peters, who's been working for several years in M+P, got it right, and the floor is yours.
Thank you. Can you? Okay, microphone's on. Very good. Thank you, and welcome everybody to this session, last session of the conference, I think, and to this presentation about my presentation about the NEMO project. I think this is the final session of this conference. I think in the last 2 days, 3 days, we've seen many projects on new high-end, well, not necessarily high-end, but at least new, modern, well-equipped vehicles with all kinds of new safety systems, battery electric vehicles, etc. This presentation, I think, also the next is more about the different category of vehicles, the vehicles that are highly polluting and highly noisy also, so that they were typically talking about older vehicles that have been tampered with, that are broken somehow, or, well, it's a different category of vehicles, I think, which is also important in the contributing to this Zero Pollution Action Plan goals on short notice. The NEMO project is, let me present the project as a whole first. So it's noise and emissions monitoring and also radical mitigation. So the main part and main focus of my presentation also is about the measurement side of it, the monitoring side of it. So then the keyword is remote sensing. So as it says here, NEMO will create and test a completely new remote sensing technology that can measure noise and emissions from individual road vehicles and trains in real time. So remote sensing, for those unfamiliar with the term, is, well, basically measuring things from a distance, right? So it could be satellites, but in this case, we're measuring things from the roadside. So can we measure the air emissions and the noise emissions from individual vehicles in normal traffic, in a normal traffic stream, on the normal real-world driving conditions, as opposed to type approval testing on a test track on the very specific driving conditions. I think that is the main goal for what we try to achieve with remote sensing, for noise as well as air emissions. The project's actually finished. We finished in November 1st last year, so we're done. The website's still online. You can find all the information there if you want, and also on LinkedIn. We've had a very large consortium of 18 different parties. I'm not going to mention all of them, but we've been coordinated by Cartif in Spain. M+P has been doing mostly of the noise part of it, together with Müller ABM and also Sintef from Norway. For the air emissions part of it, it was mainly Opus from Spain, who have been delivering and developing new remote sensing technology. And then there's other parties, for instance, Ricardo, who have been helping with the impact modeling and also the air emissions side of it. Well, and many other parties that we were really happy with. A very good consortium, I think. Okay, so what are the objectives of this project? What we've done is developed and improved remote sensing for both air pollutions and noise, as I just mentioned. That was the main goal of it. And we're doing it to identify individual high emitter vehicles. So we're focusing on the few vehicles, the top 1% or the top few percent of vehicles that are really noisy, really annoying, or highly polluting in terms of air emissions. And we're trying to identify these vehicles in normal traffic on the real driving conditions, so in the real world. So we're not looking for type approval, type approved compliant vehicles. I think the majority of the problem is vehicles that are no longer complying to type approval, either because they're old, because they're broken, or because they've been tampered with, exchanging exhaust systems, etc. So that's basically the goal of what we were doing. Also, other parts of the project is we've been developing a cloud platform where we could integrate all of the data, so the noise and the air emissions data together with the information about the vehicle itself, and where we could also do online and real-time analysis and classification. So and preferably within a few seconds we could identify if a vehicle was actually producing too much noise or emission, so that you can directly communicate this back to the drivers, so to influence their driving behavior, for instance. I will get to that a bit later, and also to the authorities. And separately, we have been looking at mitigation measures for noise and air quality. So then we're looking in more traditional mitigation measures, such as noise barriers and pavements. But here we are looking for noise barriers and pavements that are good for noise as well as air quality. So that I think is the new aspect here. And I will shortly mention it also later. And we've been doing pilot applications in several cities around Europe, in Madrid and Barcelona and Florence, in the Netherlands as well, and some testing developments also in, for instance, Rotterdam and Munich, as I will explain later. This is basically what we have been doing, trying to achieve in this NEMO project. The results presentation, so I will go into some of the results. I will be, as we have been doing mainly the noise part in NEMO, I will focus a bit in the next few slides on noise. I do have a slide also on air emissions later. As I was discussing with Professor Pluymers just a while ago, noise is a slightly underrated topic anyway, so I think it's good that we focus on this a bit more specifically, at least for now. So what we have been doing, remote sensing, I think has been around a little longer for air emissions than it has been for noise. So for noise, we've had to start from, well, more or less zero. Our colleagues from Leuven did have an unmanned traffic noise measurement system that they've been using in this, that we've been developing further in this project. So what we do is we measure sound, of course, so the maximum sound level during a single pass-by. We measure the sound spectrum. We measure some indicators of low frequency noise, which could be particularly annoying. But besides noise, we also try to measure indicators for the driving behavior, so the vehicle speed, but also following the speed over a certain time so we can get the vehicle acceleration. So, well, as you can imagine, vehicles are much more noisy when they accelerate heavily. So, and also, we try to measure the engine speed from the audio signal. So if you have a certain frequency tone in the audio spectrum and you know the number of cylinders in the vehicle, then you can calculate the engine speed. That's what we've been trying to do. It's not perfect, I will say, but at least it gave us some information about the vehicles that driving in high gear or in high RPM values. And also we're measuring the distance to the microphones, also from the audio signal actually, which is important at least to know if the vehicle is driving on the left side or the right side of this, in this case, multi-lane road. And then we also got some vehicle data from the license plate. We're not looking for, we're not yet going to enforcement, and we do not want to know whose vehicle it is. We don't care, at least not for this project. But we're looking for information about the technical information about the vehicle, so the category, the mass, the power, fuel type, etc. And for privacy reasons, we store these license plate only as a pseudonymized, unrecognizable code. So we cannot reverse this back to knowing which vehicle it is, but we do store it as a code so that we can at least see if the same vehicle has already been measured before. So we can combine multiple measurements of the same vehicle on different days and times. So that's what we've been doing. So it's privacy safe. well, the location I just showed you is actually one of the development locations we had in Rotterdam. So it's this location. It's an 80 km/h road, and we measured some 50 meters beyond the traffic lights. So we had both traffic, when the light's green, we have traffic at 80 km/h or slightly higher constant speed. But we also had vehicles that are accelerating when the light turns from red to green. And we also see, and you see that also in the graph there on the left, is marked with the 2. So we have the vehicles driving from the side road on the main road, which are accelerating slightly heavier at lower speeds. So we had some 260,000 pass-bys in 4 months, which is quite a lot. But we did some, so if we have a lot of data, then we can be quite critical about the data. So we did a quite heavy filtering on the quality of the data. So quality is about meteo, for instance. So we only had measurements on the dry weather and low wind conditions, for instance. We had pass-bys only where we have accurate speed and also acceleration values. And the signal-to-noise ratio, for instance, is an important factor. So we got down to 54,000 vehicles after this filtering. Mainly 80% was passenger cars. Very low amount of motorcycles, unfortunately, which is, I think, what the next presentation will also be about. In the graph here, you see the noise level, maximum noise level of each vehicle versus the vehicle speed. And as you can see, it's not really a speed problem. When people listen to very noisy vehicles, they may say that, well, these vehicles are driving so fast in my street. But in this location, it's not a matter of speed. It may be a matter of acceleration. Vehicles may be accelerating heavily and aggressively, but it's not a factor of speed. And also what you see in this graph is that actually the top end of this graph is more or less a horizontal line. So the loudest vehicle at 20 km/h are just as loud, equally loud as say the loudest vehicle at 80 km/h. So on the lower end you see a clear upgoing line, which is basically the vehicles that have no engine noise but just rolling noise. From rolling noise, the tire noise, we know that it increases with speed, as you see here. But on the top end, where you have the noisy vehicles, it's not very speed dependent actually. It's more dependent on acceleration and engine speed. Which is already a conclusion from this graph, and I'll get to that later. So if you have all these measurements, then one of the main questions is, what is actually a high noise emitter? It's not defined in regulations, at least not yet. Well, it is defined in type approval regulations, but there's no currently roadside noise limits. Any vehicle above 85 decibels is a high emitter. There are no such regulations just yet. So what is a noisy vehicle? Well, you can look at vehicle class, for instance. Of course, trucks make more noise than passenger cars, and motorcycles also make more noise than passenger cars. We know that, and I think to some extent we are okay with that. So in assessing whether you consider a vehicle to be a high noise emitter or not, you can distinguish between different vehicle categories. So that's one. Then you could look at speed. Vehicles that drive faster make more noise, basically mainly because of the tire noise, as I said. So also at 80 km/h, you see that the difference between the loud vehicles and the not so loud vehicles is much smaller than at lower frequencies, right? So it would be important to consider speed also as a factor in whether or not we consider vehicles to be noisy. And then you could look at driving behavior, so acceleration and engine speed mainly, which gives an extra, say, a variation of noise levels at the same speed. And whether or not you take this into the equation depends on what you're doing. Are we looking at noisy vehicles, or are we looking at noisy drivers? So is it about noisy driving behavior, heavy accelerations, not so talented in shifting gears maybe? Or are we looking at noisy vehicles that have been tampered with, so broken exhaust systems, sport exhaust systems, all kinds of systems that could be there. It could be a combination of both. Sports exhaust vehicles are typically driven by people that like to accelerate a bit faster than others, maybe. So I think the very noisy would be a combination of both. So we try to capture this in a classification model, a model that can say which vehicles do we consider to be a high emitter and which not, or maybe something in between. You could have more categories, but let's focus on high emitter or not. And our ultimate goal was to build an advanced, say, machine learning type of model that's actually based on the type approval regulations. So can we prove from the roadside that a vehicle is not compliant with type approval regulations? And we've, to cut it a bit shorter, or we've had to conclude that I think it's really not possible, at least not in the way that you can enforce type approval results in a legal sense. We can use type approval to get an idea of what is a reasonably expected noise level for a vehicle. Whether we can use we can be inspired by the type approval regulations and tests. And also, well, we get some inspirations for the modeling, but using a single roadside measurement under, say, arbitrary driving conditions is just not enough to prove in a legal sense that the vehicle is not compliant with type approval regulations. Is my conclusion for now, at least given the current type approval regulations. So what we've also been doing is, and also a disadvantage is that if you want to do it the type approval way, you need technical vehicle information about what type of vehicle, what engine, what etc. And you can get these, in the Netherlands, we can get this data from the license plate registry database, but it turns out that the Netherlands may be the only country where you can get this in real time from the vehicle database. So this actually turned out to be quite a problem for many European countries. And also some of the information that we would need is actually not registered in the vehicle registry database. So even if we could have access, it's not complete enough. So a simpler model will be based on relative levels. So then we're just trying to prove a vehicle is more noisy than the others, much more noisy than the others. And that's what we've been trying to do in this graph here. And then we've corrected for vehicle speed. So we've using some statistics and some simple machine learning, we've been estimating or establishing a reference noise level for a particular vehicle based on its vehicle category and subcategory, fuel type, for instance, and also on the driving conditions. So given its current speed and acceleration, what would be a typical noise level for this vehicle at this moment? And then we look at the difference between the actual measured level for this vehicle and, say, the established reference level. So then you could say a vehicle is much more noisy than the others under similar circumstances. So that's basically what you see in this graph. So here we do not no longer have this speed dependence. It's the same measurement set as I showed you a few slides back. And you see that the main noise emitter, so the top 1% is more than 10 dB louder than, say, the rest, the majority. I'm not calling it an average because we didn't actually use the average for resonance, but we used the 20% percentile value here. But 10 dB more noisy than the others, and you see that also that the high emitters are mainly at low speeds and high accelerations, and not so much at 80 kilometers per hour. So I think that's clear also from this graph. Okay, that's the noise. For air emotions, remote sensing, I should have put an Opus logo here because I got this slide from them, and it's basically if you have any specific questions on this, well, you can always ask me, but I think I'll at some point refer you to them. What Opus has been doing in this project is developing, validating, and piloting a new prototype of their earlier existing remote sensing devices. As you may know, these remote sensing devices for air emissions use light and laser technology. So they measure, they send light through the exhaust plumes of individual vehicles in traffic, and using, say, chromatography techniques, then they can identify the concentrations of different amounts of pollutants in the exhaust plume. I hadn't heard of this technology 4 years back. I'm actually fascinated that it's already so advanced, and they've advanced it further in this project. They now have systems that can also work with multi-lane roads, for instance, by taking doing the measurements from top down rather than from the side of the road. They've patented and tested this equipment here, and they're working on standardization, starting in Spain and hopefully expanding that to the rest of Europe. They've been checking in this project also that the individual high emitters that were identified from the roadside were actually also, well, taken back to periodical technical inspections, and they were indeed proven to be non-compliant. So, and it was a confirmation of that the roadside measurements can be verified, at least to some level of accuracy at say, lab measurements. And there were also experiments in Florence with notifying owners of these vehicles by letter that they were actually not compliant anymore. And there were also some people, I don't have numbers here, sorry, but there were some people that actually took their vehicle back for technical inspections. Okay. Some other project results that I unfortunately do not have much time for now as well. We did successfully integrate everything in a cloud platform that was able to do this in real time, so that we can communicate back to the driver within, say, a few seconds. So that would allow for, say, a LED sign on the other side of the road saying "you're too loud," which is currently what Amsterdam is experimenting with, for instance. But also through an app or emails or letters, as in Florence. We've been also doing noise remote sensing for rail. For those of you who are interested in, so there we would be able to identify noisy wagons within a train, rather than, say, noisy vehicles in the stream of road traffic. But so that's also possible. There has been quite a lot of work on developing new pavements for both urban roads and peri-urban, so motorways. And as I said, pavements that are not only low noise, but also low rolling resistance, so good for fuel consumption, and be able to capture tire road wear in the void content of these roads. If you have any questions, if you're interested in pavements, then, well, I advise you then ask me some questions, or my colleague Ronald, who's here in the room. We've had recovering from a very interesting conference yesterday with some 200 people online, also organized by Cinea on pavement. So it's a whole topic in itself, but I'll not go into it now. There were also developments of an urban noise barrier that could stop noise, but also filter particles and NOx in an urban situation. And as I said, we had some pilots in different cities around Europe. Okay. Mid to long-term expected impacts of our project. Well, so what we've developed is remote sensing for air emissions and noise, and I think this technology is now close to mature. TRL levels 7, 8 maybe, so to measure real-world vehicle emissions from the roadside under circumstances. I mean, there are obviously, if you have a say 6-lane road with a crossing and all kind of pedestrians, there may be situations where it's just not possible. But under circumstances, this is very well possible and mature technology. And if you want to use this technology to address and get rid of these noisy and polluting vehicles, I think there's basically 4 ways you could do it. So it could be about enforcement, so basically helping the police with their roadside inspections, making it more efficient, making it also more objective, so they do not just capture the youngsters with a hat on in the car, but also more objectively by using equipment. Well, this could be a high emission. This should be the vehicle that you could stop. I think for air quality, it was already shown that the success rate of police enforcement raised from just a few percent to 50% if you use this system as a, say, pre-selection system. So then it's about roadworthiness. It could also be about market surveillance, which is actually what the Commission was main interest was, as it turns out, for this kind of equipment. So gathering data on vehicles that should be called in back for, say, market surveillance. The market surveillance guidelines in 2020 requires member states to screen a number of vehicles that are on the road already and get them back for testing and see if they comply with type approval limits. And well, such a system could help with identifying which vehicles to select for this. You know, if a BMW or a random other brand would pop up in our lists more often than others, then that would be a good candidate to call it in for market surveillance. Then a couple of weeks ago, we also spoke in another session about UVARs, so urban vehicle access restrictions or low emission zones, basically. Currently, systems that are focusing on low emission zones, so you cannot enter the city center if you have a Euro 4 or worse vehicle, for instance. That is basically done on say, your license plate, and so the vehicle registry, so basically on your type approved limits. But I think the real problem is vehicles that are not compliant with type approval, that make more noise and pollute more than they were originally doing, right? So for UVAR access control, if you really want to focus on the really annoying and polluting vehicles, which I think is the goal for UVAR access control, then you should introduce some kind of in situ measurement, so remote sensing. And it could be about awareness. As I said, you could inform drivers and vehicle owners about, well, the fact that they are annoying and also polluting. I guess for noise, in most cases, they will know that they are producing too much noise. They have ears, right? But I mean, for air quality, it could be a good option to inform them about this. But even for noise, I think informing them, at least letting them know that it can be detected, then it may give them some form of awareness that they should be doing something about their vehicle or their driving style, or both. And actually, this is the road that we are currently following after the project with currently the city of Amsterdam, but we're also seeing some other cities interested in doing this. As long as legal options are not available, then awareness may be the only option that we are currently able to do. And that brings me also to the last slide. So I heard on Monday the opening speech by Rosalinde van der Vries from the Commission, who asked for, well, what can we do in terms of regulations and standardization? Well, we have some options from our project. We actually wrote a white paper on this as well, which I would love to get on her desk somehow. I don't think she's in the room now, but so let me start with bullets 2 and 3 then. So it could be about standardization of remote sensing. If you're going to if you're going to use these systems for some kind of enforcement or even access control, then you're going to have to show that these vehicles comply with some kind of quality standards for the measurement, right? So, and these quality standards do not yet exist for remote sensing. So I think it's very important that these are developed. And as I said, Opus is doing something in Spain already for noise. We have ideas as well, but well, this should be up and running in hopefully not too long. And it could be about roadside limits, and I'm mentioning this 2014 directive, which is the directive for roadside inspections. And the roadside inspections directive does not yet have any clear limit values for air emissions as well as noise. And also specifically for noise, remote sensing is not yet an option. So for air emissions, remote sensing is mentioned in this directive as an option for the police or for road authorities to identify vehicles being too noisy. For noise, the only option there is subjective evaluation by the officer, right? So basically the police just using his ears, but using equipment for this is not yet an option. So that is one of the recommendations we have for the Commission to start considering to change this and introduce some limits as well. Back to the first point, which has to do also with the Zero Pollution Action Plan, maybe as our introductory speaker mentioned. These noisy vehicles, let me focus on noise because that's my expertise. It's just a few vehicles, right? And for noise, traffic is judged by yearly average noise levels, so LDEN levels for people who are into it, so yearly average noise level. So the contribution of these high emitting vehicles to the yearly average noise level of the entire traffic is just very limited in terms of these yearly average noise levels. So if we're going to get rid of these levels and stay focused on these yearly averages, and then reducing these number of vehicles is not going to have a big impact. But my idea is that the impact on the actual annoyance and the actual health that people experience from road traffic in general is much more influenced by these high emitters than would be visible from the yearly average noise level. So in terms of dose response functions, so the WHO produced a new dose response function in 2018, the blue line here. My idea is that we would not so much reduce the dose, but we would change the annoyance, the response, right? So I think the whole people's attitude towards road traffic will improve if we can get rid of these type of vehicles. If you ask people about road traffic and about road traffic noise, then they will. I've been doing some lecturing to students about traffic noise, and if you ask students to mimic the sound of a car, they will go vroom vroom, right? So this is what people associate with traffic noise. So if you can get rid of the vroom vroom and go to shh, I think we would solve a big part of the problem in terms of perception and annoyance. Okay, well that's one of my missions, personal missions in this project, to get this across to the public. Let me know if it worked. The last thing is that we would also be for the Commission to start doing some measurement campaigns for market surveillance, so gathering some data all around Europe, so they can establish some real in-use values and databases that you could use to for instance, as input for roadside limits in the periodical technical, maybe also in the PTI, but certainly for the roadside inspections. We have more recommendations in the white paper if Ms. van der Vries is interested. But, thank you for your time. For any questions, you can ask me, or you can visit our NEMO website at any time, today or even in the future. Yeah. Thank you.
Thank you. Thank you very much, Bert, for this very thorough and interesting presentation. I'm sure there will be plenty of questions. We'll leave them for the Q&A session. And,
Yes.
And for now, we can pass to the next project. I have the pleasure to present you Professor Leonidas Giachristos, who's a mechanical engineer, professor of mechanical engineering at Aristotle University in Thessaloniki. And he will be presenting the Lens project, which touches upon similar aspects with NEMO and with a different category of vehicles. So the floor is yours.
Thank you very much, and welcome to this, what I would call an old-fashioned session of pollution and vehicles that make noise and so on. But I see there's still interest in these aspects, and I think there is very good reasons for that. There are still vehicles that do that on our roads, and the vehicles that I'm going to be talking about are the L category vehicles. So for those not familiar with the UN classification, L category vehicles are basically motorcycles, scooters, mopeds, three-wheelers and four-wheelers. So indeed, I will be following up on what Bert was discussing before on the NEMO project. Our project is not finished. It's actually ongoing. We haven't even met the midterm of the project. Soon with Salima, we will have to review it. So it is still ongoing. The coordinator is Emission. Emission is a spin-off of our university, and I am coordinating this project on behalf of Emission. I would call this project to be an what we call EARPA project. We have a lot of EARPA partners in that. So we have IDIADA, we have RVTH, we have TNO, IFP, and we also have the pleasure to collaborate with quite many actually manufacturers of L category vehicles. And I would call it a success story, and this was something that, you know, it troubled us at the beginning, but I think we have found a very good balance. On one hand, to be able to deliver techniques that will capture, let's say, the bad doers, the ones that emit beyond what they should emit in terms of noise or pollutants, and at the same time have OEMs in our group that will provide technical advice. They will provide vehicles for testing. But let me also say what I have found out is that they are also learning, because measuring emissions on the road from L category vehicles is not a really straightforward procedure. So I think we are all in a rather steep learning curve in the project, and I think we work in a very, very nice and balanced fashion between researchers and manufacturers of these vehicles. I would say that I see a lot of Maurizio in this project because one of the targets was to measure particles on the road going down to 2.5 nanometers. Let me say this has been a very challenging target from the beginning. Measuring particles, even in the lab, is challenging. Now imagine you have to do it on board a small vehicle, and also to do it in remote sensing fashion, like what we've heard from Bert before on NEMO project. And we have actually, I wouldn't say fully validated a system yet, but a system is being developed that will be able to measure particles down to 2.5 nanometers on board the vehicle. The main developer of that is TU Graz. And we will also be doing remote sensing by, I shouldn't say remote sensing, roadside measurements by point sampling, using diffusion chargers that go down to 2.5 nanometers. I will be showing you a little bit on that later on. We are also going to do onboard noise monitoring in the real world. Again, I'm going to show you the developments there from RVTH. In-field measurement of gaseous pollutants, PN and noise, similar again to NEMO, but now focusing on L category vehicles only. And then we also had the mission to measure non-regulated pollutants. In that we include, for example, ammonia and nitrous oxide, ammonia because many of these motorcycles use enriched combustion for performance. And I guess we all know, those coming from the old-fashioned world, that rich events produce a lot of ammonia, so we need to detect those events. And nitrous oxide also could be a byproduct of ammonia formation in a catalyst. So we are, with Prague University, we are developing a compact FTIR that we will be using for on-road measurements, again, of those non-regulated pollutants. Okay, so further to on-road testing, we have a big campaign. It is ongoing. We have to measure 150 vehicles in the lab from all major L vehicle subcategories. We also have to do identification of tampered L category vehicles on the road, and we have 3 campaigns. 2 of them are confirmed. One is nearby in Leuven, another one is in Paris. And then we are also looking for an Italian city because of the big proportion of L category vehicles. We have been looking for Florence. Then we learned that Florence has some kind of local election, and this is blocking some of the measurement that we have. So now my colleagues from IVL are really looking where we should go. There are several options, but we don't want to go away of Italy, as I've told you, because of the large share of motorcycles and the very passionate, of course, link between riders and motorcycles in Italy. Okay, I should focus on results and not on planning. I've told you we are on month 17, but I can already give you some results. We started the laboratory testing by 2 manufacturers, BMW and KTM, giving motorcycles to the partners that will do the actual testing to do what we call a round robin. So in the end, we need to have a database of 150 motorcycles tested in different laboratories, and we need to make sure that the measurements collected in different laboratories are comparable with each other. So basically what we do with a round robin exercise is that we take these 2 motorcycles around the different labs. We do actual testing in different regulated and unregulated conditions. We compare the results, and we try to make sure that, you know, the laboratories measure exactly the same exactly the same result on the exact vehicles. The labs, as you can see, that take part in this round robin so far have been Emission and LAT, the university laboratory, IDIADA, TU Graz. Lately, IFP, they have built their own chassis dyno for motorcycles, so they will also be part of the round robin. And Prague University initially were part of that. We are still working on that, but there are some technical issues, so excuse me, IFP will most probably taking over some of the testing at Prague University. We have finalized the protocol for regulated and non-regulated pollutant testing, including, as I've told you, particle number in the lab. I should say here that in the lab there are 2 methods for doing sampling of gaseous pollutants. One is what we call the closed CVS, the other is the open CVS. I have to say, I mean, those of you that are even slightly familiar with exhaust of motorcycles, you can find exhaust which are of any kind of shape. They can be cylindrical, they can be octagonal, they can be ellipsoid, they can be any kind of shape, and then you have to connect there and take the exhaust out of that. It's not always straightforward, as you can imagine. We don't have the circular pipes that vehicles have. That's why we are trying to do what we call closed CVS, or to sample the exhaust from those shapes. So you can see, for example, here we have a scooter, and for every single vehicle, we need to have an individual manufacturing of a component that we will couple in the exhaust. In very extreme cases that we are not able to do it, and we do open CVS, it is allowed. So basically, you don't connect a closed pipe in the exhaust line, but you suck air from around the vehicle, you suck all of the exhaust produced by the vehicle, and then you do the analysis in this case. This is very good for gaseous pollutants, but for particle number, you have to be careful. And as I've told you, in the lab, we also do FTIR kind of measurements for non-regulated pollutants, PMP particle number, and we also do total particle number going down to 2.5 nanometers. But I think before I go to the on-road, I would like to show you where we started. This category specifically, because riders have access to the hardware, very easy access to the hardware of the vehicle, and you know, especially the exhaust of the vehicle is what we call part of the personality of the vehicle. There is a tendency to tamper with those vehicles for a variety of reasons. So what we started this project with was to do a questionnaire between different riders to see to what extent those vehicles are tampered. And we circulated, as you can see, 666 questionnaires. We also did face-to-face interviews with riders. And just because, I mean, the people mostly that we got hold of were people with a kind of special relationship with their motorcycle. We found that 75% they have done some kind of tampering with their motorcycle. And you will see, or you will not see because the characters are very small, but down there, the line that you can see, more than 50% is aftermarket silencer. So more than 50% have changed the silencer on the vehicle. And sometimes the silencer also has the catalyst in. So by removing the silencer, you might also be removing the catalyst of the vehicle. And then you go to the technical inspection and you bring back the original silencer with the catalyst and the vehicle complies with the test, but then you just take 3 screws out, you bring your own non-catalytic silencer or muffler, and then, you know, this is how the vehicle is being used in reality. So, especially for this vehicle class, it is mandatory that we have monitoring of the performance of the vehicles on the road. And then you can see there are also list, or you cannot see, apologies for that. There is a long list of other methods of tampering of the vehicle, any kind of thing, changing the intake, changing the gearing, changing the ECU, removal of the air filter. As I've told you, it's very easy to access the vehicle. So even 20% of these people had a software modified ECU. So basically, all of the type approval of the vehicle is scrapped by changing the program of the ECU. This is not so common in passenger cars. I've told you also what we wanted to do is to see under what kind of driving conditions these vehicles emit high noise or produce high pollution events. There was an analysis mostly by TNO on previous tests conducted identifying which of those conditions that you can see in the blue box here are let's say with high probability to produce either high emission or high noise events. And what we said is that we should design both an in-lab testing schedule, but primarily an on-road testing campaign that, as much as possible, will be able to cover all of these events. Not so cold engine start, straightforward why. You see transition from constant speed or acceleration to deceleration phases because, you know, the throttle of these vehicles is very sensitive, so they could produce some high emission events. Some other cases are not very easy to replicate. So driving at maximum rated speed is not always straightforward how you do it with super sport motorcycles. Strong accelerations, how strong those accelerations can be, it's difficult. When you have the equipment, you know, on the back seats, if there is a back seat on some of these, you cannot go full throttle. So what we've said is as much as possible, we will try to identify these events, we will try to characterize the vehicles as much as possible, but not everything is very straightforward to do. We also, as I told you, developed a protocol, what kind of data we have to record, especially for the roadside measurements. Again, I need to say here, we are not focusing only on, for example, Euro 5 motorcycles, the latest vehicles that are equipped with OBD. Several of these vehicles are older technology, they're not equipped with OBD systems. Still, we have to identify what is the engine speed, what is the gear that the vehicle is driven, what is the exhaust temperature. So we have to develop a system that will be able to do it as much as possible, but I have to tell you that for some vehicles, very small ones, scooters, for example, we might not be able to do a very thorough recording of all of the operation parameters of the vehicle. A big effort during this first phase of the project was to see what kind of devices we have for on-road measurements. So you see that 4 partners here have developed, 3 partners have developed, 1 partner uses a commercial system. The only basic commercial system that we can carry on board most of the motorcycle is this system offered by company AIP. It's a compact kind of PEM system. It can be used for road vehicles, but it can be used for motorcycles. It's in the order of 25 kilos. But since not all of us had access to a system like that, we have Horiba in the system, in the consortium. Horiba are developing their own SEM system. Then IFP, they have been also developing their own system. It has been used on passenger car. It is adapted for motorcycle. And also Emission, ourselves, we are developing our own SEM systems. So when we say SEMs, we mean sensor-based emission measurement system, basically using either electrochemical sensors and or NDIR kind of sensors, and some more advanced sensor like the black carbon sensor that we are using in our case. We are able to measure regulated and unregulated pollutants on the road. Actually, we are the only ones that we have started doing on-road testing with our system. This is the advantage of being in the south of Europe. Northern Europe is not very convenient to do actual testing in the winter with this non-commercial equipment, but the planning is that by April also TU Graz and IFP will start doing on-road testing using these systems. Again, as I told you, there are challenges here. One very big challenge is how to measure exhaust flow rate on the road from these motorcycles. It's not straightforward. The exhaust flow of motorcycles is highly pulsating. There is flow from the engine to the tailpipe, but there is also flow from the tailpipe to the engine when you have these highly transient events. As you can understand, if you can see here, you know, the muffler is suspended. You cannot put something after the muffler that will add another 10 kilos there. So we have to be engineering very inventive how we can measure the exhaust flow rate. Sometimes we cannot measure the exhaust flow rate, so basically what we do is that we record the driving profile of the vehicles and the altitude of the vehicles on the road, and then we replicate the same testing on the chassis dyno, and we are measuring the exhaust flow rate on the chassis dyno, and then we calculate the pollution on the road by doing the testing in the lab. So you understand 150 vehicles to do all of that is a quite challenging program, but this is how Horizon projects are now. Many challenges, the budget sometimes drops, so just a message here. We are also, our colleagues at RVTH, they have developed an onboard noise measurement system. So we are also equipping the vehicles that we do on-road testing with microphones on board. We have identified optimum locations for this, so we're trying to record noise events while the vehicles are driven on the road, because we would also like to give feedback how these vehicles perform under the different conditions that I've mentioned before. I guess we need to give some time to discussion, so let me accelerate a little bit. In terms of impacts, if this continues to be relevant, we would like to give recommendations for emission regulations going to particles down to 2.5. Through the tests that we do, but also the remote sensing or on-road test, we would like to provide feedback for tampering methods, as I showed you here, but also how we can detect tampering, similar to NEMO. The fact that we are having collocated noise and emission testing might give us some additional information how to detect, for example, mufflers that have been removed, because this creates both higher noise and higher pollution. And we hope that by what we will be giving to the cities in terms of driving patterns, monitoring of emissions, enforcement of regulations, we will be able to reduce pollution up to 10 dB. Of course, this will depend on the specific use case and location. And as Bert said before, it's a very noise and annoyance is a very different thing. And when we decrease background noise, for example, by introducing electric passenger cars, and you have solid and singular events of high pollution, noise pollution, or noise levels from single motorcycles, the annoyance level, although the average noise level is lower. So this is something to take into account in regulations. For us, let's say clients of the results are city authorities, obviously, that want to do something with upcoming noise and pollution problems, end users, and we invite stakeholders to our groups, and enforcement agencies. Those could be regulation, but also testing centers and centers that do PTI, if we would like to have more effective control of these tampered vehicles. So thank you very much. We are still ongoing. If there are ideas, requests, or guidance, we would be very happy to receive it. And thank you very much for your attention.
Thank you very much for another very interesting presentation, which I'm sure has spawned a lot of interest for the next phase of the project, and we're looking forward to the future results. And now I'm going to pass the floor to Bert, who is going to moderate the Q&A sessions. I'm sure you have plenty of questions.
Yeah, you can leave it on. Thank you. Well, indeed, also from my side, thanks to the two speakers for the interesting presentations. We started a bit later, so I think we can afford a few more minutes on the Q&A. Maybe first of all, is there a question from the audience?
Yeah, Christoph Schanders from FEV and IAPA. Also, thank you from my side for very interesting presentations. So both of the projects developed their own measurement equipment, as I understand. Is there a plan to bring that into production or to, let's say, to commercialize this equipment? And in which time frame?
If I may answer for NEMO, so the air emissions is already being commercialized. I think these systems are available through Opus. For noise, I think the system that we used in NEMO is developed by Müller BBM. I've asked them. I don't think they have plans to actually commercialize it on a very short notice. There are other systems that we are currently also as MSP experimenting with in Amsterdam from other that are commercially available, at least in a, say, TRL 8, 9-ish state. I think the noise measurements are okay, but just making sure that it's actually that vehicle and not another vehicle. That is, of course, the critical part here. So that's also what we see other system developers, say, struggling with or trying to improve, using video images, for instance, or whatever. I know there's other systems as well, but we've at least found one system, and I can give you some information that is commercially available that we're using. Yeah.
If I can also respond from my side, indeed, for, let's say, regulated pollutants, there are commercial systems. For particle number, the development is done in Graz. In our case, I mean, I know a company in Graz that might be interested in this kind of technology, but anyone else, of course. And for noise, I think, as Bert said, the actual hardware is not very sophisticated. It is actually the algorithms that you use to do different kind of detection. In our case, we are collaborating with Leuven for the development of the algorithms. But also in your case, you are commercializing, I think, this kind of algorithms. So again, I would say this is a technique that if regulation decides that would like to go into this direction, it will be straightforward, you know, how to commercialize it.
Thank you. If I may add another question. So, Bert, I think in one of your slides you stated that it would be hard to identify a manipulated vehicle from the noise level, because there would be so many, let's say, different factors influencing the noise level, like the acceleration, like the speed, and the gear. But in the end, you also were quite optimistic about the possibility to identify the vehicles. So.
Yes, so it is a matter of definition. So what I meant with what is very hard is that it's very hard to prove in a legal sense that a vehicle is not complying with the type approval regulations. The type approval tests are based, as you may know, I think it's also for air quality the same case, on test track measurements and even a combination of different kind of measurements on the different very specific driving styles, right? So, and you cannot reproduce this measurement from the roadside and under arbitrary driving conditions. And I think so reverse engineering that, say, that's what we tried, to reverse engineer the single roadside measurements by getting as much information as we could about the driving style and about the vehicle itself, back to, say, at least an accurate estimation of what the type approval testing would give. I think that is shown to be not possible. Unless, and that maybe that's also one of the recommendations that we had in our white paper to the Commission, is if the results from this type approval test on slightly more detailed information from the type approval test would be registered in the vehicle registry database, then these could be used as, say, reference values for roadside testing. So I think that would need more information in the type approval registry.
If I may add on to that, sorry for interrupting, Christophe. Throughout the week, we have heard the term digital twin quite often. We are talking here about remote sensing, which makes sense today, but maybe to both speakers, do you see the opportunity or the option to go to on-vehicle sensing? You're already experimenting with some things, such that basically your vehicle becomes the sensor, and that you have this information in the digital twin of the vehicle, whatever that may look like, because then you have all the information available. And then you could even, because you talked about changing awareness of people driving vehicles. When I'm driving my car, I see an indicator how green I'm driving. Could we have an indicator how quietly I am driving? Maybe a question to both of you.
Well, as I've told you, for motorcycles, we do the actual testing. And we are trying to identify those events that produce those operation and driving events that produce high noise events. Now, whether this will be integrated on vehicles, I don't know anymore. I don't see that, there is research and priority for new vehicles in this area because of electrification. And I'm not entirely sure what the plans for new motorcycles are going to be. I think there is a plan from the European Commission. I don't know whether this will be materialized or not, but if we are turning into electric vehicles, then as we've discussed, the main noise sources is tire and aerodynamic. And okay, the motor on a motorcycle will make some noise, but this goes together with speed. So basically by controlling speed you can control noise on electric vehicles. I don't think it's an acceleration problem anymore.
Not for electric vehicles.
Yes.
For electric vehicles, noise may not be an issue at all. Tire noise will be, but not. Anyway, I think the second thing you mentioned is actually a very relevant point. So there's no indicator in the vehicle how polluting you are, and not also how noisy you are. With respect to noise, I would say, as I mentioned, people have ears, right? So the vehicles that we are now currently focusing on are so loud that people are they're aware that they're loud, right? They're doing it on purpose, probably, right? So they do not need an indicator. For air quality emissions, I could imagine that it would be needed to let people know that they are polluting. If you're going to fine people, then well, as you say, if you come to find people for driving too fast, you can only do that if they know how fast they're driving, right? So that's a very valid point. About the digital twin, interesting. We could get a lot of data, useful data from the vehicle about accurate engine speed values and also throttle position values, etc. That would be really useful to help identify whether a vehicle is complying with type approval or not. Then we need the help of the manufacturers to do it, and they would probably have to be obliged to do so by the Commission, by regulations. I don't know, that could be a slow route, I'm thinking. But, so the Zero Pollution Action Plan goals are set for 2030, which is in 6 years, right? So I think something from the roadside would be quicker to develop maybe than the digital twin route, but it would certainly be helpful, yeah.
Okay. Maurizio was first.
Thank you for both for the huge amount of work. I'm looking forward for the 2.5 nanometer results. But I would jump on the offer to ask questions to specialists on the road emission. And I mean, you mentioned a pavement that is low noise, low rolling resistance, and it wasn't clear completely low emission or capturing the emissions. And in that case, I would wonder if the emissions are higher. I mean, one of the possible solutions I heard is about basically putting rubber into the pavement. And then on that one, I'm wondering whether we improve one thing, but we pay it with more abrasion and so on. But if you can, or the expert can elaborate on this aspect. Thank you.
Yeah, so about pavements we can talk for an hour, I think. We're not, at least, well, there are experiments with, to be clear about the rubber, there are experiments with putting rubber in surfaces. We heard also about it yesterday. I'm not a fan of it. I advise people not to do so, indeed. And also other chemical components to improve pavements is difficult. But well, it's my personal opinion. I know that there's others working on putting rubber in pavements. But no, what we are talking about is a pavement that is low in noise, low in rolling resistance, and also that is able to, so with regards to tire wear, there's two aspects. So it could be low in generating tire wear. So say if you have a smoother surface, then it will, I think, will cause less tire wear. We do not have proof for this yet, unfortunately, also not in this project. The other thing that we were looking at is the ability of porous surfaces, like we have in the Netherlands. A lot of them, they're able to trap the tire road wear particles in the surface and then, filtering the surface or cleaning the surface so you can at least prevent particles from ending up in the environment. We had only a very small amount of time and budget to look in it in this project, but we did do some measurements and there are some results, and there's definitely something that we're going to follow up on in other projects, this particular aspect. Low noise pavements, so there's been, these exist, this is not so new. That it's new that we combine it with microplastics capturing. And also low rolling resistance, which also is related to surface texture. And actually, if you have very smooth roads, I think it's good for both noise and rolling resistance and wear, actually. So I think that is something that to be.
Okay, thank you.
I disagree, but that's another discussion. I mean, we have lots of very fine-graded roads in the Netherlands, and we do not have high numbers of accidents. So, okay. Maybe as I said, we can talk about it for.
Indeed, maybe the pavement discussion can continue during lunch. We have maybe time for one final question. I saw some people raising their hand. Yeah.
Michal Klimasina. I have a quick question regarding remote sensing, both for emissions, exhaust emissions and noise. When you have a dense traffic with more contributors, how you can differentiate the contribution from a particle vehicle?
From
a particle from a concrete vehicle. So if like noise, when you have 5 cars around, how do you know who is the one who is the biggest contributor to the noise?
Yeah, so I can answer for noise. For particles, you need to measure in the individual plume of an individual vehicle. So I could imagine if you have 2 vehicles driving next to each other, it's more difficult. But I couldn't answer. But for noise, it's basically the same thing. It is if you have vehicles driving behind each other, it's very well possible. There are limits, of course. If you have vehicles driving 2 meters apart at 120 kilometers per hour, it's not going to work. But if you can see at least in the noise levels, the difference between between one vehicle and another. We can separate them, and we can also, using some algorithms, identify the contribution that the second vehicle has on the noise level you measure for the first, right? So this can be done. What is difficult that we found out is vehicles driving next to each other. If you have a multi-lane road situation driving in the same direction, so how are you going to identify from the roadside that it's two vehicles and not one? I could imagine that you could have other equipment, right? You could have a radar detector or laser detectors detecting that at least you have two vehicles and then you have an invalid measurement. Well, that's better than having a bad measurement, right? So we'd rather have get rid of the false positives than the false negatives. So I guess with some other, we didn't experiment with it, but if you have some other equipment to detect this, then you can at least get rid of these measurements. I do not yet see. We've also been experimenting with top-down microphones. I'm not sure if we will be able to do it in a multi-lane situation. No.
If I just chip in, so for single lane is straightforward, you can do for pollution. For multi-lane, then you need to have the top-down system. But one has to accept that, out of the many thousands of measurements, a large proportion of them will not be valid ones because you cannot detect. But the good thing is that you can install it there for several days, several months, so you can do capturing, and you will lose a lot, but you will also get many, many valid ones.
Okay, and maybe with that we can conclude this session. If I'm informed correctly, in 5 minutes we have a plenary closing session downstairs, so maybe we can all make our way there, and then I'm quite sure that the speakers will still be available during the lunch break for final discussions. Thank you.